So something I like to do is make these builds as easy as possible for myself, and a way I can do that is by putting things together on the bench in a way that saves steps when it's a bit more awkward when they're attached to the plane. So I've currently got all the horns ready, and to do this I've roughed up these surfaces ready for the Hysol epoxy. So naturally, with their applicator gun, I want to do all of these in one go. So with those ready to go, I would like to get the linkages ready now. Now, a common mistake made, and an easy one to do, is that there are two bags of these ball joints, and there are two very different style ball joints. We'll see here I'm holding the flange style. So this one is designed to go on the servo arm, on a metal servo arm. So it sits flat on the flange, and then the washer style hex screw holds it down like so. So it's really important that these go on the servo arm, and then we have this parallel style one with a very small extrusion, I suppose, at each end, and this one is designed to go between the horn and sits ended like that. So anyway, that's just the first thing to note. So what I'm going to do now is I'm going to take one of each, and I'm going to screw these in together. So what I'm going to do is, I'll probably do this off camera, I'll hold this with two pairs of pliers, and I'm going to screw them in about 4 times each side until I've got all of these ready.
I find it smart to get as much done at the bench as you can. In this case, I'm just getting the servo horns ready and the linkages. So I've just screwed these in a little bit, ready to go. And I've also sanded the glued section down the bottom and given that a quick clean with isopropanol. Got it nice and grippy for the Hysol epoxy to stick to. This is really good because it does two things. It keeps the servo horn aligned up perfectly when you bolt it to the plane, and it saves you a bit of labour when you're putting the control surface together. Sort of one of those jobs you can do while watching TV. So here we're looking at the Hysol. It's really smart if you can get all your control surfaces ready to go. That way you're not wasting the precious, slightly expensive Hysol. First thing I do is just make sure the horns fit. Sometimes they're a bit too tight and you need to make adjustments to the hole, but these are dropping in really nicely, so they'll be ready to go. I'll just make sure that's sitting nice and flush and pop them back out, and we're ready to go. I don't trim the covering behind these plates because I figure that's not the part doing the load, that's just there for alignment and aesthetic reasons. So Hysol gun's ready. Something actually Tim Nolan taught me is to just run a bit of glue out on a sample first. You can see it actually coming out of the nozzle there. It's not properly mixed at the beginning, so you don't want that to be what's holding your horn in. So I'm just going to run a bit out until it comes out clean. It doesn't take much. And I'm also going to keep this little bit of plastic as a sample. The sample is going to be really handy because it's going to let me know that the glue is set properly. If you don't have a sample outside of the plane and glue's all set in theory, you don't have a way of actually knowing. So now I'm going to squirt some of this in, a bit like a caulking gun. It's a really nice, neat way to do this. I like to get a lot in there. I'm really not stingy about this. Don't care about a bit of extra glue weight. And a little bit of mess if some pops out the side. Doesn't bother me in the slightest. All that I'm worried about here is making sure that probably the most critical thing I do putting the model together is durable enough to last the distance. We put a lot of load through these control horns, and the last thing you want is one coming out. That'd just be a disaster. So I've stuck that in. I think a tiny bit of glue's come out of that, but that's fine. No real
I
stress
always
there.
start by putting the elevator
And I'm
servos in
really
first
pleased with the
because
result.
it's basically one of the jobs I enjoy the least due to access. But these are probably overkill with my ultra long bent nose Nipex pliers. Basically my favourite tool in the shed a lot of the time. Just reach in here, grab that lead, pull it through, feeding it through. I'm trying to make sure I don't pull it hard or damage the lead in any way. Slide that in through. And you beauty, servo's in. Doesn't that look all shiny and nice in there? Actually, I made it a bit of a complaint in the unboxing video for how big that slot is, but now that I see how much easier it makes getting the servo in, I'm not quite as upset. Just showing off a quick tip. I'm sure everyone knows this by now. A few people have posted about it, but I thought I would. Getting these rubber things on, that part's pretty easy, but when you've got a whole plane of inserts to do, it can get really tedious trying to do it with pliers or, hurting your fingers or that kind of thing. This method makes life a hell of a lot easier. As you can see, I'm doing this clumsy as hell because I'm trying to watch the phone screen as I do it, but that's it, done. Obviously, to anyone who's a beginner out there, make sure you put these brass inserts in from the bottom. The flange is supposed to sit on what it's screwed to, and the screw is supposed to clamp on the rubber. And this provides, allegedly, a bit of vibration insulation for the servo. Hope that was helpful. So this lightsabery looking doodad is my fancy ES121 electric screwdriver. Really handy for getting these screws started. You can't drive them all the way in, but gets them going enough that I can use the old trusty T-bar to get them the rest of the way. Yeah, most of the way. But yeah, basically now I'm just going to drive them all in and then get ready to throw some thin CA in those threads and we'll go from there. Sometimes you just got to treat yourself putting these screws in there. Two things. One is, if you're a servo manufacturer and you don't provide hex head screws, please provide hex head screws. I'm not even going to get into why Phillips head is just rubbish and miserable, and I hate it, and it's horrible, and it's Henry Ford's fault. But if you want to get really fancy, get yourself one of these ES121 electric screwdrivers. I can just chuck that in there. Won't drive it the whole way in, but gets it started. Makes this, usually a chore of a job. Really pretty straightforward. Let's get that started. Yeah. Well, you get the idea. Of course that fell off because I'm clumsy and I'm trying to reach around the camera. And I'll get some of this in the frame. There we go. All started. So, finally put some wings together. And I'm just going to show you my process for servo matching. I'm using the Boomer AR Extreme RS. Pretty nice little unit. To excuse the nest in there, I'm still in the dry assembly phase. I've made my quick connect wing connectors, so that's all sorted, ready to go. So yeah, basically the start of my process is that I will set up my radio so that I'm viewing a log of the current. Sorry about the reflection from the light there. It's auto ranging, so it's a bit all over the shop at the moment. But you can see the current live, and that's really handy for balancing servos. You can see if there's any jamming or anything going on, because that'll shoot right up. But basically I use my phone as an angle gauge. I've set the aileron deflection to be 45 up, 45 down on the inner aileron, with this outer one disconnected. And the next part of the process for me is I'm going to put the screw in this and use the resistance of the screw against the ball link to determine drag and to see if I need to make changes. Interesting looking at my data screen here, because you can even see if I'm just physically loading up a servo here, and you can watch the current rise and fall. I'll try and do it with my hand, so nothing twisting on the servo, and you can see that current going up. So now I'm just setting the baseline endpoints here. So off camera I've got the Boomer RC control board, and I'm just feeling there's still a bit of drag on that. As I push it down, it's pushing the screw a bit away, so I need to reduce the throw there just a little bit until there's basically no drag that is on them. I actually go a little bit past that. I start to go, okay, so I'm starting to get some drag again. I'm going to go back a couple of points back this way, and there's just nothing on that. And while I'm doing this, I'm looking at my telemetry screen, and I'm just seeing a baseline of 0.45 amps, which appears to be the baseline for this. So now I'm going to look at the upper limit. So I'm going to do the same thing, because I've got this on a rotary. I'm watching my current here, and it's still staying nice and low. I'm seeing, so the current's gone up a bit, and so I can feel I'm under a bit of load there. I've stalled the servo out a bit. So the servo needs to have its throw increased a bit, and there we go. As soon as I've got that servo just a little bit further, it's come right up. The current went up to about 1 amp, but has all of a sudden dropped back down to where it should be. I'm actually going to take you over there to have a look at that telemetry screen. So you can see that was when I initially moved it, and as I've slowly gotten it correct, you can see it coming right. So now I'm ready to start the multi-point matching. So as a part of confirming that everything's looking good so far, I'm just looking at my telemetry screen again. This is current, it's auto ranging, and I'm just going to move, oh, it's my ignition. Hello Evie. I'm just going to move the aileron around. That's auto ranging. The top of the range is 0.5 of an amp, so it's not a lot at this stage. I'm just looking to see if there's any, tight spots or parts where the current's going right up, but that all looks really, really sensible in the sort of noise floor range. There's a bit as it comes up to the top, but that's partially the weight of the actual aileron. Another thing, just to confirm that nothing's binding, I've just got this screw loose. What I'm going to do is slowly move the ailerons whilst confirming that the movement here is completely free. Maybe a little tight spot there, so what I'm going to do is I'm going to go into 15-point servo matching, and I'm just going to bump that section.